Hello everyone. My name is Rhiddhi Siddique and I am from section 5. Today I will present my final project for computer network titled Design and Implementation of a Secure Enterprise Campus Network using switching, routing, and wireless technologies. This project focuses on designing a secure and scalable enterprise network for ABC Tech Corporation, including VLAN segmentation, routing, wireless access, redundancy, and security mechanism. This presentation is divided into 6 sections: introduction, network design, core configuration, wireless and security, project extension, and finally, testing with conclusion. A modern enterprise depends heavily on a stable and secure network infrastructure. Without proper segmentation and security, communication becomes inefficient and vulnerable. For this project, I designed a complete enterprise campus network for ABC Tech Corporation, supporting 3 departments: administration, engineering, and sales, together with wireless users. The main requirements were VLAN segmentation security, redundancy, and secure wireless connectivity. This slide shows the overall network topology using the 3-tier hierarchical model. At the core layer, I used a multi-layer switch for routing and central traffic control. The distribution layer contains switches and routers that connect network segmentations. The access layer includes end devices such as PCs, laptops, access points, and the server. Different VLANs were assigned for each department to isolate traffic. This slide shows the IP addressing scheme. Each VLAN uses a separate subnet: VLAN 10 for administration, VLAN 20 for engineering, VLAN 30 for sales, VLAN 40 for wireless, and VLAN 99 for management. This structured addressing makes routing and troubleshooting easier while improving network organizations. Basic configuration was applied to all routers and switches. This included hostname assignment, password encryption, SSH remote access, user authentication, banners, and saving configurations. These configurations improve security and ensure devices can be managed remotely in a secure way. I created VLANs to logically separate departments. This improves both security and performance because broadcast traffic stays within each department. Trunk links were configured between switches so multiple VLANs could travel across the same physical link. To allow communication between different VLANs, I configured inter-VLAN routing using the multi-layer switch. Each VLAN has an SVI, which acts as its default gateway. This allows devices from different departments to communicate whenever permitted by security policies. I used Ether channel with LACP between MLS and switch 1. Ether channel combines multiple physical links into one logical link. This provides 3 advantages: higher bandwidth, redundancy, and load balancing. To prevent switching loops, I configured Rapid PVST+. The multi-layer switch was configured as the root bridge. I also enabled port fast and BPDU guard on access ports to improve convergence speed and block unauthorized switches. For routing, I used both static routing and OSPF. Static routes were used for predictable paths, while OSPF provided dynamic route sharing between routers and the multi-layer switch. OSPF improved scalability because routes update automatically when topology changes. The multi-layer switch also acts as a DHCP server. Separate DHCP pools were created for each VLAN. This allows all wired and wireless devices to receive IP addresses automatically, reducing manual configuration. I implemented HSRP, which provides gateway redundancy. If the active gateway fails, the standby device automatically takes over. This ensures continuous network scalability with minimal downtime. For wireless connectivity, I configured two access points with WPA2 security. Separate SSIDs were created for admin and sales. Wireless clients receive IP address through DHCP and are placed into their respective VLANs. To improve switch security, I configured port security, sticky MAC addresses, unused port shutdown, SSH only remote access. These features help prevent unauthorized access and MAC spoofing. Now, the extension section. I used ACLs to restrict sales VLAN from accessing admin and engineering VLANs. This ensures sensitive departmental resources remain protected. I implemented NAT with PAT, so multiple internal devices can share a single public IP for internet access. This improves IP address efficiency. A guest wireless network was created on VLAN 40. ACLs prevent guests from accessing internal company resources while still allowing internet access. I added a voice VLAN to support future IP telephony deployment. QoS prioritizes voice traffic to reduce latency and jitter. I configured NTP for time synchronization across devices. This is important for logging, security auditing, and troubleshooting. All major configurations were tested successfully and documented in the report. This includes inter-VLAN routing, DHCP, HSRP failover, wireless connectivity, OSPF, security features, NAT and Ether channel. All 10 test categories have passed. During implementation, I faced issues with DHCP snooping and with STP convergence. These were solved through troubleshooting, verification commands, and incremental testing. This project have improved my problem-solving skills significantly. In conclusion, all project requirements were successfully achieved. The final network is secure, scalable, redundant, and enterprise ready. This project allowed me to integrate switching, routing, wireless networking, redundancy, and security into one complete working solution. With this, I will be concluding my presentation. Thank you so much.